A bead artist drills a tiny hole from the top corner of a cube bead to the opposite bottom corner of that bead. So it's a cube bead. Each edge of the bead is 1/2 centimeters. How long is the hole that she drilled? So if I'm interpreting this properly, let me draw that cube bead, which I will just draw as a cube, a big cube here. Nicer cubes have been drawn in the history of cube drawing, but I'll try my best. So let's see. This is my best shot at a freehand cube. I think that does the job reasonably well. We could even, if this cube was transparent, you could even imagine kind of that back side over there, and the base of the cube if this was a transparent cube. They tell us that each edge of this cube bead, right? They call this a cube bead. Each edge of the cube bead is 1/2 centimeters. So this is 1/2 centimeters. This is 1/2 centimeters, and that is 1/2 centimeters. And then they say that they drill the hole from the top corner of a cube bead to the opposite bottom corner of the bead. So from the top corner to the opposite bottom. So I think they're talking about the longest diagonal that can fit in the cube, going from the back right top corner over here to the front left bottom corner right over there. That's the longest diagonal it could fit. So let me draw that. So it would look something like this. This is the distance in question. How long is the hole that she drilled? That is the distance that we have to figure out. And let's see how we can think about that. And this is a bit of a classic in terms of figuring out a distance, the longest diagonal of a cube or some type of a rectangular prism. And the trick here is to see that this is the hypotenuse of a triangle, although the triangle isn't completely obvious to you just yet. And to think about this as the hypotenuse of a right triangle, what you have to do is visualize the diagonal of the bottom face of this cube. Think about this diagonal right here that I'm drawing. So the diagonal of the bottom face of this cube. If you think of it that way, then all of a sudden we have a right triangle that's kind of going across this cube. This is a right angle over here. So if we could figure out, we know what this length is. This is 1/2 centimeters. If we could figure out the length of this orange side right here, this part that's going diagonally across the base of the cube, then we could use the Pythagorean theorem to figure out what the distance in question is, this longest diagonal of the cube. Now, to figure out this orange side, you just have to visualize the base of this cube. Let's look at this base. Just if we were just in the cube looking straight down at the base, it would look something like this. You'd have this side. Let me color code them. It'll make it easier to visualize, I think. You have this side right here, which I will do in this blue color. So I'll draw it over here. You have this side in that blue color. And then you have this side over here, which I'll do in the magenta color. You have this side over there in the magenta color. They are both of length 1/2, so I'll draw them of roughly the same length. And then you have this orange side that goes across to the bottom of the base of the cube. And I'll do it as the same orange dotted line right there. Just like that. Let me extend this side a little bit. And we know this is a right angle. This is a cube we're dealing with. So this is a right angle. We know that this side is 1/2 centimeter. We know that this side, right over here, is 1/2 centimeter. So if we wanted to figure out this diagonal, or this length right here, we can just use the Pythagorean theorem. We know that 1/2 squared, if we call this, I don't know, if we call this right here x, we know that x squared, the hypotenuse squared, is equal to the sum of the squares of these two guys is equal to 1/2 squared plus 1/2 squared. Or if we want to solve for x, we could say x is equal to the square root. What's this going to be? The square root of 1/4, that's 1/2 squared, plus 1/2 squared, which is 1/4. Or what's 1/4 plus 1/4? So x is equal to the square root of 1/4 plus 1/4, that's 2/4, or 1/2. Or you could write that as 1 over the square root of 2. Now we could rationalize this, but I'll leave it like that for now. It'll keep things simple. So this distance right here is 1 over the square root of 2. Or we could say this distance right over here is 1 over the square root of 2. So if we were to draw the right triangle, where the hypotenuse is the length of that hole, let me draw that right triangle. So we have our hypotenuse, which is this long thing over here. Let me just draw it like this. That long thing over there. We have this side over here in yellow, this side right here. We have that side right there. It is of length 1/2 centimeters. And then we have the side we just figured out, this side right here, that x side. This right over here. right over here. This side over here, it is a right angle. We just figured out this length. It is 1 over the square root of 2 centimeters. 1 over the square root of 2. Now, to figure out the length of the hole, we can apply the Pythagorean theorem again. If we have, this is, let me say, h for hole, length of hole. Actually, even better, let's say L. L for length. Then we can say that L squared is going to be equal to 1 over the square root of 2 squared. 1 over the square root of 2 squared. We're just applying the Pythagorean theorem, plus 1 squared. Plus 1 squared. And once again, we know that this is the longest side. It's opposite the right angle. So it's going to be the sum of the squares of the other two sides. And so that's going to be equal to, so we get L squared is equal to, what's 1 over the square root of 2 squared? Well, 1 squared is 1 over the square root of 2 squared is 2. And then you're going to have plus 1/2 squared. 1/2 squared is plus 1/4. So L squared is equal to 1/2 plus 1/4. 1/2 plus 1/4 is what? Let's do it over here. 1/2, we can write it as 2/4 plus 1/4 is equal to 3/4. So this right here is equal to 3/4. So we have L squared, I changed the shades of green just there, is equal to 3 over 4. So L is equal to the square root of 3 over 4. So we take the square root of both sides. You get L is equal to the square root of 3 over the square root of 4. What's the square root of 4? The square root of 4 is 2. And we're done. The length of the hole that was drilled in this bead from this corner over here all the way over here is the square root of 3 over 2 centimeters, because everything we've been dealing with has been centimeters.